So 1 to the top, negatives, product, the denominator, 1/3 is the cube root. Okay, we wanted to look at 70. 70, log x plus log x squared minus 4 minus log 15 minus log x plus 2.
So can we pause for a moment and try
Yes.
this on our own?
Yes.
And then we can do that?
Absolutely.
Is that x plus 2?
The last one, yes. You really have nothing to do, right? It's just one quick answer.
Wait, what's the last number?
X plus 2. Sorry, my apologies. I ran out of room. Ready? I'm ready for the answer.
Is it, do you start with log?
Yeah.
Or, and then is it a quotient?
So, we have log. What do we have at the top?
X in parentheses, x squared minus 4. Okay. And then at the bottom, 15, and in parentheses, x plus 2.
Good.
Okay.
However, I have to factor this.
Way to
Log.
ruin it for us.
So can you give me the factor form, please?
So x minus
2 x plus 2.
Wait, so I was gonna ask you, why did we do that on the top one? Because we had a difference in squares, we had x squared minus 25.
Because I cannot simplify. Even if I factor into x minus 5 and x plus 5, I'm not going to go anywhere. But here, here it's worth it.
Okay.
So this is log x, x minus 2 over 15.
But you don't come on these.
Is this clear? Is that a yes?
So we need to know that basically with the squares.
Yeah, we need to know what we learned from the day one.
But no, I'm saying like you got to know what the answer would be, because let's just say if something.
No,
else
you
was at the
have to
bottom.
look at it and say, okay, if I factor, will I be able to simplify? Yes, then I'll do it.
So you
If
do
I
that.
factor and I can't simplify, then I wasted my time. It's not wrong. It's not wrong to write this, but you will not be able to simplify it.
So you could, okay.
Yeah,
I saw that. I was wondering.
that's fine. Yeah, we didn't because I looked at the top and I couldn't simplify it, that's all. But very good point. Okay, now you're going to understand why we did what we just did. 4.4, exponential and log equations. Exponential and log equations. Let's start with exponential. How many different types of equations we know? We counted a long time ago. There were 8. Linear, quadratic, polynomial, quadratic in form, radical, absolute value, equations with rational exponents, and rational equations. So we're adding 2 more to the list, and that's it. Just 10, promise. So exponential equations. 2 to the x equals 2 to the 4th. Is this a radical equation? Is it rational? Is it absolute value? Is it linear? Is it quadratic? Is it polynomial? No, it's what we are talking about. It's exponential because the variable is the exponent. Perfect. We do not cross out the 2's. We do not simplify in any way, shape, or form. This is what we think and how we think. 2 numbers are equal and they have the same base. what do you think has to happen to the exponents? They have to? Exactly. There's no other way. X equals 4. Done. Well, of course, however, this is just not even a warm-up. Ready? On page 514, let's continue with 20. On 514, 8 raised to 1 minus x equals 4 raised to x plus 2. Well, well, well. Let's go back to our first example. Notice what happened here. The left-hand side and the right-hand side were presented with the same exactly. So I'm hoping, I always hope, that both sides can be presented with the same base. So what will you do to 8? What is the only way you can rewrite 8? And you will say as yes to the
third.
very good. The same thing with 4. What is the only way I can present 4 as
Well,
good? So we are close. We are getting close. But now I have to copy the base, and please tell me what happens with the exponents. I copy the base and then what operation? Yes, I multiply. Very good. 3 minus 3x equals 2 to 2x plus 4. Indeed. I copy the base, multiply the exponents, and of course I have to distribute. Now you understand, although this looks complicated, I am back to the same question. Two numbers are equal and they have the same base. What has to happen? The exponents must be the same. So here the same thing. Two numbers are equal and they have the same base. Oops. What has to happen? Mandatory, otherwise these two will not be equal. So two numbers are equal and they have the same base. What has to happen to their exponents?
They have to be equal to.
Exactly. 3 minus 3x must equal 2x plus 4. There is no other way. The left-hand side will not be the same to the right-hand side if those powers are not the same. So please do not simplify. I'm not simplifying 2 with 2. I'm not canceling. I'm not moving 2 to the other side. Nothing of that kind. It's just a concept. Two numbers are equal and they have the same base. Therefore, their exponents must be the same. Okay, moving on. I move 2x, negative 5x. I move 3, I get 1, so x equals negative 1/5. Let's choose, let's say, 22. Any questions on the previous problem, please? 22. E to x plus 4 equals 1 over e to 2x. Remember what my hope is. My hope is that I present both sides with the same base. The left-hand side is very clear. But can I present the right-hand side as e to a power? And then I'm back to the very simple situation. Is there any way I can rewrite 1 over e to 2x as e to some power?
Could you put -1?
Negative 2x.
Or like
E, yes, e to negative x is 1 over e to 2x.
Say it one more time.
Yes. A to negative n is 1 over a to the nth power.
I don't think I wrote that down somewhere. Alright, so. Oh, because it's negative, and it's negative because it's at the bottom?
Exactly, yes.
Okay.
So then I'm back to the same situation. Two numbers are the same, equal, and they have the same base. What must happen for sure? Can anyone dictate what must happen?
X plus 4
X plus 4.
equals negative 2x.
Very good. I don't like keeping the variable on the right, but this time I'm going to do it. So 4 equals negative 3x, so x equals negative 4/3. So see if anything else before we move on to other types of exponential equations, more difficult than this one. Please see if you want anything else from 1 through 22.
On 514.
On 514, yes. Yes.
16.
16 it is. 7 raised to a fraction, x minus 2 over 6, they say equals the square root of 7. Excellent. Very good pick.
Yeah, because I'm
Good. Good. So the left-hand side is done. There is nothing I can do to the left-hand side, but I'm hoping that there is a way of presenting this piece with the same base.
7 to the 1/2.
Very good. See, as my grandma used to say, if you torture someone long enough, they will remember it. Good. So I'm done. Two numbers are equal and they have the same base. What has to happen? Please dictate what has to happen. Mandatory.
X minus 2 over 6 equals. Wow.
That's it. We know how to do this. You either cross multiply because it's a proportion, or you multiply both sides by 6, whatever. 2x minus 4 equals 6. 2x minus 4 equals 6. 2x equals 10. X equals 5. Any questions? Please, please, please. Go ahead. Yes?
Because I hate fractions. So it's just cross multiplication
Yes.
at this point. with
2
this
times
fraction.
x minus, because it's a proportion.
Okay.
But if you remember, if I have something like this, I cannot cross
You
multiply.
have to multiply.
I have to move everything to one side or multiply everything by 6, eliminate fractions.
Okay.
Yeah. But this is a proportion, so I can do this. Is this okay? Good. So we choose another, or we move on to the next level? We move on to the next level? So we learned something about exponential equations. As long as I can present both sides with the same base, all I have to write is the exponents have to be the same. Agreed? But this will not always be possible. Of course, right? So let's look at more sophisticated situations. Allow me to choose the first one, and then you choose the next. For example, 28. 19 raised to x equals 143. And no, 143 cannot be presented with a base of 19. So there is no way ever in which I can present 19 and 143 with the same base. This time is not going to happen. Okay, I want to discuss something and connect concepts before we solve this problem, okay? So if I have, let's say, the cube root of x equals 2, how do I solve this equation?
Break it down first. You went multiply both sides by it?
Almost by 3.
Raise.
Yeah, right, that's what I mean.
Right. Raise both sides to which power?
3.
I want to raise to 4. Will that eliminate the cube root?
Yes.
Not power 4.
No.
You are correct.
3.
I am incorrect. But the point I'm making is I cannot use power 4 or any other power. But why I can use only 3? Because this power is 1/3. And when I multiply power 1/3 by 3, what do I get?
1.
Exactly. I clear the power. I clear the cube root. So what are these two operations, x cubed and the cube root? How are they called? Excellent. That's what I wanted. They are inverses of each other. And now I would like to come back to our problem. So keep this in mind. Okay. So since I cannot present 19 and 143 with the same base, I have to apply the inverse mechanism. Since this is an exponential function, what will be the inverse function to the exponential? It's that function that allows us to bring the power in front. The log. The natural log and natural log on both sides. So like here, I applied power 3 to both sides because power 3 was the inverse of the cube root. Here I have to apply the natural log because that will be the inverse of the power. So now x is in front as a factor. Natural log 19 equals natural log 143. I want to show something with the calculator for a moment because I don't want you to be ever scared of natural log. So natural log of 19, natural log 19 is just a poor number. This is it. So don't get scared when you see natural log 19. It's just the number. What is it? 2.9. When you see natural log of 143, what is it? Just a simple number. I don't really care what it is. But if I plug it in, then I get an approximation. If I keep it as natural log of 143, it's exact. So I have to keep them together. I'm not going to plug them in like that. So coming back, what is x equal to? This number over this number. Exactly. Natural log 143 over natural log 19. Remember, this is not natural log of 143 over 19. Do not get confused. This is just this number divided by this number. Let's say you say, I don't understand this, or I'm not sure. Show me that this is the correct number. And I'm going to show you. And I'm going to plug it in 19 raised to the x. So let's grab the calculator and divide natural log 19. I'm sorry, natural log this one divided by natural log 19. And then how do I check?
Square of 19.
I take 19.
I mean, not square.
Power in parentheses the previous answer, close. I want this number. I don't want to truncate it. When I hit enter, what should I get if my answer is correct?
143.
Correct. Excellent. Well done. Because if I don't get 143, my answer of 1.69 approximately is incorrect. Any questions before we look at other problems? Is this okay?
Yeah. So the natural log, you said, that takes you to the two numbers being inverses of one another?
Correct.
But log doesn't.
Log is the inverse of the exponential. So when I solve an exponential equation, if I apply log to both sides, then I can bring that power in front. And it becomes a linear equation now. But only if I apply log to both sides, I'm allowed to do that. Log is the only function, property 3, that allows us to bring the power in front as a factor.
But not the natural log.
Any log.
Any log.
As long as you use the same log to both sides.
So can you explain to me really quick the difference between log and natural log one more time?
Just the base is different.
Just the basis.
But it doesn't matter. So it's a very good question. And I would like to do this problem with log. Okay? So if we have, so our answer was approximately 1.69. Okay? Sorry. So 19 raised to x equals 143. And you can say, I don't want to apply natural log. I want to apply common log. Why am I applying natural log or common log? Because that's all I have in the calculator. I don't have any other base.
Right.
I normally, I would have said, why don't we apply natural log base 19? But then I don't have the, I have to use the change of base formula to find log base 19 or 143. So I'm applying either natural log to both sides or common log to both sides because that's what I have in the calculator. Okay, so the same thing, I have x log 19 equals log 143, and the same thing, log 143 over log 19. And I guarantee you there is only one number. This will be 1.69. It must be. So check it out. So log 143 divided by log, common log of 19. The answer must be the same. Why? Because there is only one number that I raised 19 to get 143, not two numbers. Did we get the same thing?
Yeah.
Good. Good. Okay, let's continue practicing.
So what's the answer? Oh, it's
1.69.
also it would be 1.69. It's going to be
Yes.
a number.
So you either consider the approximation or you consider the exact.
Okay.
This is exact. I approximated it just because I needed to check. So this is the approximation, which I really don't care about. But if you ask me how much money I have in my pocket, I'm not going to tell you natural log of 143 over natural log of 19. I have to approximate, and I'll say I have $1.69.
Which one do we have to rate it? Which way do we have to rate it on the test?
So normally the exact is the correct answer. You will approximate if you want to check. Now, if there is a war problem, that's what I was saying. If there is a war problem, you're not going to leave the answer as how much money I have in my pocket. I'm not going to say natural log of 143 over natural log of 19. I would say $1.69. But if it's just an equation, no, just an abstract meaning, the exact is the best. But if we're trying to determine how many rabbits are blah, 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 then I'm not going to say natural log of 143 over natural log of 19. Very good. So let's practice some more. What about 32?
Is this the last one?
For today?
Yeah. No.
You wanted it to be the last one?
No, I mean, I was asking, like, is this the last type that we're learning? Or?
Yes, today, yes. We do have time to start log equations, but I don't want to. I'd rather practice exponential equations. And we can do the last section of this chapter and the log equations on Wednesday. Okay, I was looking at 32. Please choose the next one you want. 4e to 7x equals 1,273. So we're trying to solve this equation for x, of course. So what do I need to do first? Look at it carefully and say, something you always asked us to do first, if there is a need. What is it? Exactly, of course. Clean it up. Excellent. So we have e to 7x equals 10273 over 4. Don't calculate anything. What now?
Do you see if you can divide it? Oh no, you leave it.
Say it again.
Do you do anything with the 4? Or-
No. Just leave it as a fraction.
Okay.
Don't worry about it just now. Good. So then what?
Take E7 to 7x should be.
So this is a number. Forget about this. It's whatever it is. I don't care. So what do I have to do in order to bring 7x in front? Exactly. Exactly. That's my only way. How do I eliminate the cube root? Cubing both sides. How do I eliminate an exponential? Applying log. How do I eliminate a log? Applying exponential, because they are inverses of each other. So then I bring 7x in front. Natural log e equals natural log 10273 over 4. Don't worry about this. This is just a poor number. I know it looks sophisticated, just a poor number. Okay, now I would like to discuss this. Natural log E is unknown, but I know that this is equivalent to, what is the base of natural log?
E.
Excellent. E to what power is E? Exactly. So this is 1. Because we're here, we didn't finish. Can you please tell me what is log of 10? The base raised to which number is 10? What is the base?
10.
10 raised to which number is 10?
One.
Log base 8 of 8. Log base 7 of 7.
1.
Of course. So this is 1. So we have 7x equals natural log 10273 over 4. I need x. Do not calculate anything. We will calculate everything in one step. So how do I determine this?
Divide all of them.
Remember parentheses? Ready? Let's put this in the graphing calculator. Ready? So natural log. Parentheses already pop up. 10273. 10273. 10,273. Divided by 4. Close the parenthesis. And everything divided by 7. I get approximately 1.12. Because I don't want to leave it. I have the exact number, but I would like to check. Okay, now I have 4 times E to 7 times the previous answer, and see if I get that. Ready? 4 times 7 power. Careful, it's not going to work. We have to put 4 multiplied. 7 power, parentheses. Oh no. I'm sorry, I deleted my stuff, so I don't have the number anymore. I have to do it again. Sorry. So natural log 10273. I made the error that I already told you several times not to do. Okay, I need this number here. Okay, now 4 multiplied by 7 power in parentheses. It's 7x, right? 7 times. I'm sorry. It's E. It's not 7. Where did I come up with 7? Okay. 4 times E in parentheses. 7 times the previous answer and close the parenthesis. When I hit enter, what should I get if my answer is correct? 10,273. 10,273. So therefore, we know that the answer 1.12 is correct, approximately. So we checked. Okay, we have time for one more and then we'll stop. Please choose anything from 23 through 48.
What page are we on? Still
514. The most difficult one is 42, in my opinion.
42.
Yes.
Okay. But it's 7 and 2x plus 1? I'm on different.
You're talking, no, page 514,
Right.
problem 42.
You think that's hard?
Yes.
Oh, okay.
I'll show you why. I'll show you
Maybe
why.
like the first one we did.
So 42. 7 raised to 2x plus 1 equals 3 raised to x plus 2. Question. Can I present 7 and 3 with the same base? Never. Okay, perfect. So what is my only hope?
Or you put it as a log and then you put that as
So then 2x plus 1, if you omit parentheses, you're only multiplying 1 by natural log. So you have to put 2x plus 1 in parentheses and then natural log 7. Can anyone dictate the right-hand side?
X plus 2.
But in parentheses, natural log 3. Remember, these are just simple numbers. They look sophisticated, difficult, whatever. Don't. I have to distribute these numbers to both and remove parentheses.
Why isn't it in the front this time?
But it is in the front. Remember, log of x squared is 2 times log x.
Okay.
So the power goes in front and it's multiplied, but since these are two terms, I have to put parentheses. Because the power has to multiply natural log 7. If I omit parentheses, only 1 multiplies natural log, not the whole thing.
Okay. I mean, is that X right? Like, why isn't the 7 the? Why isn't it in? Oh no.
The
Why
power goes in front as a factor.
Oh, you did just say that. I'm sorry.
That's okay. We have to get used to it. This is new. If you have any idea, when I learn something, I ask the same question 10 million times. And sometimes you have a much fresher mind than I do. So for me, it's even more difficult. And I ask the same question several times. And you have to. It's the only way. Now, is it clear? So x plus 2 goes in front of natural log 3 in parentheses. I have to remove parentheses. 2x natural log 7 plus natural log 7 equals x natural log 3 plus 2 natural log 3. Do we agree with this?
Why are we breaking it down?
We have to remove parentheses.
Oh, that's the only way you can
We
do
have
it.
to remove parentheses because we are solving for x. And x is found in two different terms. Therefore, this term moves here and this term moves here to the other side. I have to separate them. Now it's a linear equation. So 2x natural log 7 but minus x natural log 3. Do you agree so far? I moved this term to the other side, it changes its sign. I move this term to the other side, 2 natural log 3, but minus natural log 7. I have to separate the terms that have x from terms that don't have x. This is always the case. And now you could just say, combine these. And I'll say I won't, because I can't. But there is something I have to do. What can I do to solve for x?
Oh, you can write that.
Exactly, factor out x. 2 natural log 7 minus natural log 3. 2 natural log 3 minus natural log 7. This is a number. This is a number. How much is x? Imagine that I have here 10 and I have here 5. How do I solve for x?
Divide it.
This by this, of course, and that's it. But you cannot simplify anything. This is it. It looks sophisticated and difficult, but because of those natural logs.